Hi everybody, and welcome to our video on using the TI-84 to solve equations and inequalities. Now, this part, using the TI-84 to solve equations, we've already done that. We did that in the first lesson in this unit, but we haven't touched down on inequalities yet. So I'm going to show you how to do that in some of these later examples. But just for a review, we're going to start off with equations. So this is something you already know. This is just a little bit of extra practice. It says solve each equation or inequality below using your TI-84. That's why I have it sitting here. So let's just check out this first one. And you can put me on pause and come back to me after you do it yourself and check in that you're correct, or you can go along with me here. So we're going to press down y equals and clear out all that other old junk. And let's type in y1 the left side of the equation, 2x. So here we go, 2x, plain and simple. Hit enter. In y2, we're going to type the right side, 6. Enter. Now before you hit graph, press down window for me, because from some of our old examples, your window might be a little crazy with some bigger numbers. So would you default it back? X min should be -10. X max 10, X scale 1, Y min -10, Y max 10, Y scale 1. Okay, and let's go ahead and graph. So there's your 2x and there's your 6. Y equals 2x, diagonal, going through the origin, slope of 2. Here is y equals 6, the right side, horizontal line at y equals 6. We want that point right there where they are equal, where they intersect, where one line equals the other line. So we second trace. We go down to number 5. First curve, we hit enter. Second curve, we hit enter. And our guess, we come on over and we hit enter. And we see that x is 3. So let's just write that down. X equals 3. That's all there is to it. And you can see it works because, hey, 2 times 3 is 6. So that's a good one. Awesome. Let's move to example 2. Another review. 5x minus 2 equals 3. So we'll cruise right on through this one. In y equals, we'll clear out the old, put in the new. We've got 5x minus 2 for y1. We have 3 for y2. Our window should be good. Let's graph. Excellent. And we second trace, number 5. First curve, enter. Second curve, enter. Here comes my guess. I think they intersect about right there. Enter. And I'm getting x equals 1. X equals 1. I can run a quick check. 5 times 1 is 5. 5 minus 2 is 3. So that's another good one. Okay. Example 3. Let's cruise on down to it. Little bit more complicated, but the calculator should handle it just fine. Let's go for it. Y equals. Okay. Here we go. 3 parentheses 4x plus 2 close parentheses minus 2x. Make sure it's minus on the right, not negative. Minus 2x plus 7. In y2, 4x plus 1. Graph. Let's see what we have here. Okay, yeah, they're intersecting about right here. So my window is still sufficient. So I'm going to do second trace, number 5, intersect, enter, enter. And I'm going to bring my cursor on down. My guess is that they intersect there. I'm getting x equals -2. Excellent. You could check it. You can put a -2 here, and a -2 here, and a -2 here. And I'm telling you, the two sides will indeed be equal. But for this video, I'm not going to do that right now. That way the video will stay on the shorter side. Okay, let's go to example 4. Now examples 4 and 5 are the new part of this. And it's sort of a lead-in to what we'll be doing later on the calculator. So I thought I'd start off with something kind of basic. So let's just talk about this. It's the difference here is the symbol in between here. It's no longer an equal sign. It's saying 3x is greater than or equal to 6, right? So if you were doing this, if you were to do this inequality Granny style, and Granny had to come up with values that x could be, well, let's see. Well, you know my favorite number is 8. Let me see if 8 works. If I take 3 times 8 is greater than or equal to 6. Let me see if that's true. Well, that's 24. 24 greater than or equal to 6? Heck yeah, it is. So x equaling 8, if x is 8, that's going to work out. But there are other values that Granny could say would work out. For example, 10. 10's going to work. Look, 3 times 10 greater than or equal to 6? Heck yeah, it is. 30 greater than or equal to 6? Yes, it is. So x being 10 works. I think you can probably kind of eyeball this and think, boy, oh boy, there's a lot of values of x that are going to work. 100 would work. 50 would work. 41.5 would work. There's a ton of answers. In fact, there's an infinite number of answers if we sat here long enough. But here's the thing. In algebra, we would divide both sides by 3, right? We would divide both sides by 3 to get x alone. And we would say all the solutions that are possible are either greater than 2 or equal to 2. 2 is sort of the edge when you think about it. Let's look at Granny style with the equal to 2. If I take 3 times 2 is greater than or equal to 6. Just barely, because 3 times 2 is 6. Now 6 isn't greater than 6, but 6 is equal to 6. So that 2 right there, I think of that as kind of being like the edge of my solutions. Now in former math classes, you might have even gone so far as to make a visual of the solutions. You may have said, hey, look, if you look at a number line, and here's 0, all the answers that x can be are right at the edge, 2, because 2 will work, and so will anything greater. So you may have drawn the solution on a number line and made it sort of look like this, and filled in the dot at 2. So that's another way to represent your solutions. But here's the kicker. There's another way to get these solutions, and it's on your TI-84. And this would be the new part. So let's check this out. Hit y equals and clear everything out. Clear it. Clear it. Now, when you go to type y1, it's no different. It's going to be the left side of your inequality symbol. So we're going to type 3x in there. 3x. Enter. And then on y2, we're going to type the right side. 6. Enter. And let's graph it. And there's what you see. Now, let me blow that up for a second, okay? I'm gonna take what you see on your screen. You keep looking at your screen. I'm going to blow that up on this sheet of paper right here, okay? So here's what we've got. Wham, wham, xy. So 3x, right? Y equals 3x goes through the origin with a slope of 3. I'm not going to be perfect about it. I'm just going to go like that. And then y equals 6, which is the second or the right side of the inequality. Let's say 6 is here, right? Is horizontal. Now, the first thing I'm going to do is I want to know that point of intersection right there. This is going to be the edge. So let's go ahead. Where do they intersect? So let's run a second trace, number 5, intersect. Enter for the first, enter for the second. And let's come over to where they intersect for our guess. Notice what you get on the calculator. X equals 2. So that means that this guy right here is x equals 2. So I know that my answer has something to do with this edge where the two lines intersect. Now this would be the answer if this inequality symbol, if this was 3x equals 6, then we would be done and x would be 2. But here's the kicker. We want to know, remember what the inequality said? 3x has to be greater than or equal to 6. We want to know where the diagonal line, because 3x is the diagonal line, is sitting above, see, greater than or equal to means above, the horizontal line, because y equals 6 is horizontal. So we're looking for where the diagonal line sits above the horizontal line. Now, if you look here, can you tell? Here's the edge. I would say the diagonal line sits above the horizontal line right here. And that mess I just colored, if you look at the edge on the x-axis, goes this way. This way on the x, which equates to, if you look at the shading, top to bottom, it like matches up where we are on the x-axis. Above is to the right of x equals 2. There's nothing to the left. If you look to the left of the edge or the left here, there's nothing over here. Everything is from the edge to the right. So I'm going to have to say everything, all the x's that are greater than or equal to 2 are where the diagonal line is going to be above the horizontal line. And that matches up with the answer we got algebraically. Isn't that cool? Okay, let's look at the last one here. Example 5. We've got negative 4x is less than or equal to 8. Okay, so you could granny style it. I mean, you could sit here and pick different values of x that might work. Algebraically, let's see, what you did in your math past is you divided both sides by negative 4. So let's do that. Let's divide both sides of this inequality by negative 4. Now, do you remember that crazy old rule? When you divide by a negative in the context of an inequality, you have to flip the symbol 180 degrees. And so we would have x is greater than or equal to negative 2. Right? X is greater than or equal to negative 2. Now, let's look on the TI and see what happens. So let's go to y equals, clear out the old. And in y1, let's type the original left side, negative 4x. And the right side, in y2, 8. And graph. Okay, so now we've got a diagonal line with a negative slope. That's your negative 4x. We've got the horizontal line at 8. So let's take a look here. So let me draw this again. Let me bring this and kind of blow it up on regular paper for you. So we've got ourselves, see, this is the y-axis, the x-axis. Okay, this will be the negative 4x, okay? So very steep here. We'll make this the negative 4x. This is the diagonal line. And then up here at 8, right, horizontal. Excellent. Now, let's find the edge. Let's find where they intersect, okay? So if we come back to the calculator and we do second calculate, number 5, enter on the first curve, enter on the second curve, and let's take a guess. Okay, I'm getting x equals negative 2. So this x that hooks up with that point of intersection, aka the edge, is negative 2. So our answer is going to have something to do with negative 2. Now let's remember what the problem said. The problem said negative 4x had to be, what was the original? Less than or equal to 8, right? That was the problem. And we're doing this visually. So we want to know where the diagonal line is less than. That means below the horizontal line. Where visually is for what values of x? And that's the thing we got to catch here. In a visual sense, we're catching the values of x where the diagonal line is below the horizontal. So let's look at our picture. Where is the diagonal line underneath or below the horizontal line? Well, wouldn't that be here? All this? Now you've got to interpret that, where does the x-axis hook up with this? Well, I don't think it would go that way, because if I go this way and travel, there's nothing over there. But if I go to the right, do you see how everything to the right of -2, if I took this part of the shading here, this squiggly line, if I track that down to the x, if I track this down to the x, if I track this to the x, if I track this up to the x, all of this squiggle goes with this part of the x-axis. And so all my solutions have to go to the right of -2, greater than or equal to -2. Now look at the answer. Same. But you know what's cool? You know how here when I had to remember that little rule about flipping that? Yeah, students forget that sometimes. You don't need to remember it if you do it visually. So the TI-84 is just a fantastic tool to visually understand your algebraic answers. So really cool. We're going to be using this, trust me, as we get into this unit further, we're going to be using this when we do absolute value equations and inequalities. It's going to help tremendously with the algebra. So thanks for watching, and I'll catch you next time.